Alright, let's talk about the consorted vowel string. So you are given an integer n, so return a number of a string length of n that consists only vowels a, e, I, o, u, and are lexicographically sorted. So this is a definition of how you sort a string. So I will just quickly explain again. So you have a, e, I, o, u, right? And then you want to generate a string that is lexicographically ordered. So if n equal to 1, it's definitely just return the character itself, right? So it's going to be A individually, E individually, I individually, O individually, and U individually. So that's 5. But when n equal to 2, right? When n equal to 2, we also need to think about the lexicographical order, right? So it has to be what's from smallest to greatest, right? So A can append anyone, right? So A can append E, A can append I, A can O, A can U, right? So this is 5, right? How about E? Can E append A? No, right? This is not lexicographically ordered, so E can append E, I, O, U. And how about I? Starting from I, O, U, right? So every single time you will just have to start with your current index and current value, to be honest, and traversing again. Traversing through the end, right? Now this is pretty much the solution. So let me demonstrate the first one, the first solution. I'm going to use the char array, and I'm going to create a vowels, and I will say new char A E I O U. Now I need to return a vowel. I return the function, so I need to have a result. And in this case, I'm going to traverse my vowel with vowels, and then I will just keep adding my count for my vowel and a minus one. So this is actually mean I use my uh, current position for this vowel, right? And for many for how many times a minus one time. This is because I use this for to represent n time. And if you put in my helper function, that will a minus one time. Right. So let me write public font character this will be last chart. I'll tell you what happened. So what does last chart mean? I definitely need to compare the current chart with the with the vowels chart, right? Because I want to know, am I allowed to append? So here is it. So the base case for this one, if n is actually equal to 0, I can know the last chart will be the only chart you need to return. So this is length of 1, right? Right. So I need to return vowel for this function. Now I need to traverse my vowel with the vowels, right? And I need to see if this vowel is greater or equal to my last chart. If this is true, I'm going to swap result plus equal count. And my last chart will be the vowel, and then will be a minus one. I will keep decrement every single time, right? And this is pretty much the solution. Alright, so if you see the time, this is going to be the worst. This is because what? Traverse every single vowel. This is all of 5. But how many times you call for the count? This is going to call for n time for every single vowel, right? So this will be what? All of n to the power of 5, right? So here's a diagram. So if you have A, E, I, O, U, right? And for every single character, so and you are going to call A, E, I, O, U again, right? This is how it is, right? You have to double check it. And yeah, so on, right? And this one, so on, right? So this is pretty bad, but it passed the test. But I'm still going to talk about the time and space. The time is all of 5 to the power of 5 to the power of n, right? 5 to the power of n, and the space is what? The space is this is a space, this is a space, this is a space. You can say all of 5, which is stored in the array of the vowels, but that's fine. And let me tell you another solution. So using the recursion and starting from 2D 2D recursion for sure. So here is the problem. So I will have a 2D array. So my row will be n, my column will be vowels. But in this case, I'm going to just add additional row and column. So I will start from 0, right? 1, 2, 3, 4, 5, right? And this is 0 for n, and 1, 2, 3, right? And then so on, right? So for every single time, like this is how it is. And in this scenario, the 1, 2, 3, 4, 5 represent the possible character you can append to the table. So what does this mean? How many ways you can append only one character into a string? That's for you, right? You can append UU, EU, AU, IU, so on, right? This is only for this one. You cannot say A, right? You cannot have A right here. This is not allowed. You cannot say UA. UA doesn't allow, right? So in this table, the index, sorry, the integer represent the vowel, like the possible vowel you can append to the string. So this is U. This is what? OU. This is I OU, E I OU, and A I OU, right? And this will be it. Now, if n equal to 1, like you need to know like how many way you can return. So if n equal to 1, then think about this, like you can only append u to yourself, right? So which is u. Now OU, this is 2, this is 3, this is 4, this is 5. And if you see this pattern, you are going to return 5 when n equal to 1, right? Return 5 when n equal to 1. Okay, let's talk about when n equal to 2. When n equal to 2, this color is better. When n equal to 2, I need to know like when my n minus 1 and a vowel are allowed. So this is UU, right? So for n equal to 2, and this position is UU, right? And this is going to be one way only, right? How about this? OU, and you can have UU, OU, and then what? OO, OO, and then what? What else? You don't have UO, right? So this is 3. Alright, so this is, if you notice, you're adding the top and left to the current cell, and this is going to be what? 6, this is going to be 10, this is going to be 15, and this is the solution, right? 15. And this is pretty much the 2D. So okay, let me just stop coding. And pp equal to new int n plus 1 and then 6. I'm going to return a value for my helper function. I'm going to use the same name. I'm going to pass in the n. I'm going to pass in the vowel, which is 5. I'm passing the pp. So I was probably int and count in n in vowels in 2D array. So if n equal to 1, right, you just have to return vowels. I don't care, right? And if vowels equal to 1, that would be only character you need to return, right? And then if pp n vowels is not equal to 0, you will return pp n vowel. And I need a return value, so I will return results, right? So for every single result, right, you need to call your helper function, and then sometimes you have a -1, right? and then you have to plus along with vowels. If you use this current vowel, but it's still traversing the rest of the character, and then this will be right. And I need to assign my DPN and vowel equal to result. Right, so you can short this to here, right? And then we run a solution. This is what even. Sorry, one more thing. Where's the error? 16. Let me think about this. Oh, okay, never mind. I will do this anyway. All right. You don't need to plus equal. You will just need to say equal. Oh, I thought I did this. All right. Anyway, this is submit. All right. I still pass the test, but you need scenarios faster because I memorized this, right? So I will then definitely know the table, and I will just have to return. And let's talk about time and space. This is all of n times phi, right? Phi n, and the recursion is going to traverse every single table, right? For sure, and there will be phi n as well. But you can you can minimize to all of them if you want. All right, this is 2D. Let's talk about 1D. 1D is a little bit easy. So here's a n equal to 0, and then n equal to 1, n equal to 2, and I have a 0, 1, 2, 3, 4, 5. Alright, so you can represent A, E, I, O, U in this case. A, E, I, O, U, right? A, E, I, O, U. Let me just quickly draw the diagram. A, E, I, O, U. Okay, here's the different color. Okay, so I will initialize my 1D DP. So I will initialize 1, 1, 1, 1, 1. Just initialize. So when n equal to 1, how many way you can add into the string for n equal to 1? So length of 1 is what? Only A. Length of 1 for E is E, right? And this is E. I mean 1, 1, 1, sorry. And okay, this is wrong. The reason why I say wrong is for 1D DP, you need to keep adding for your summation for current index table. So we definitely know length of 1 for E is 1, but we also need to plus the previous one, so which is 2. Length of 1 for I is 1, so plus the previous one is 2, so which is 3, 4, 5. So when n equal to 1, you just have to return the last index in your 1D DP, so which is 5. How about when n equal to 2? And let's think about this. So n equal to 2, using the same idea, you need to add your above and left. This is 3, this is 6, this is 10, this is 15. Alright, so this is the solution. So how do you actually do this? That will be super simple. So I'll put in dp equal to new in 6, and then for int I equal to 1, I less than equal to n I plus plus, and then for int k equal to 1, k less than equal to 5, then it'll be full of about, right? K plus plus. And then dpa what? dpa k plus equal dpa k minus 1. And I'm not done yet. This is because I didn't initialize this. 0, 1, 1, 2, 3, 4, 5, 6. Right. Now I need to just return dpan. I'm sorry, dpa5. dpa5, and then this for untime you will have untraversal, and then for the character arrays all of fives, right? This is the fastest for sure. So let's talk about time. All of n times all of 5, right? So phi n, which is all of n, and then full space is all of 6, probably, right? You can say constant, doesn't matter, but I would say all of 6. And this can be if you don't know this, right? This can be doing a 2D array for sure. I pass in the 2D array. I know n plus 1 is 6, right? I initialize the first will be 1, and then starting from 1 to n, and then from 1 to 5 for the vowel, and then I would just keep adding my top and left, right? Top and left, and then this is the return value dpn, and then bracket 5, right? If you don't believe it, I just run it. And this is just slightly worse because when you use the space, it's all of n times 5. But for the time, it's going to be the same for the 1D array, right? Or all of 5 times n, right? And this is solution. And I know this video is long, and I really don't recommend you to watch a long video for the solution. The shorter the better, and definitely the quality should be the first scenario thing you have to talk about, right? So I thought this is pretty good, to be honest. And if you feel helpful, leave the like and subscribe if you want it, and I will see you next time. Bye.